Okay, so we're going to start with the chemistry of DNA replication, and that's shown here. And again, I assume this is going to be review for you guys, but I just want to go through some of the key elements of it. So this just shows the substrate for DNA replication, which I will call a primer template junction. Okay, the primer has a free 3' OH hydroxyl group, and the catalysis works simply by having that OH attack the alpha phosphate of an incoming deoxynucleotide triphosphate, releasing a pyrophosphate. And this only occurs when this base correctly base pairs with the base on the template. Okay, so hopefully that's all very clear. I want to make two important points about this process, however, which is that, well, actually, I want to start with one, which is why does it go forward? Okay, so why do we use triphosphates instead of, for example, diphosphates to do this reaction? Okay, so all of the precursors that we'll talk about will be triphosphates, and there's an important reason for that, which is that this second reaction of cleaving this pyrophosphate, okay, which is two phosphates coupled to one another, into two phosphates, drives the reaction such that it's essentially irreversible. So the reaction with the action of pyrophosphatase has a delta G equal to minus 7 kcals. Okay? But without, delta G would equal minus 3.5 kcal. Okay? And while this would still be a forward reaction, this reaction is essentially irreversible. Okay? And so the cell makes sure that this reaction goes forward by not only having it release the pyrophosphate, but very, very rapidly taking that pyrophosphate and degrading it into two phosphates. Okay, so so let's go through how this is catalyzed. So this is catalyzed by an enzyme called DNA polymerase. Okay, and what does it require? So first of all, I want to just make sure we have our terms correct. So it requires a 3' OH primer, okay, and that must be annealed to a longer single-stranded DNA with the single-stranded DNA adjacent to the 3' OH primer. Okay, and this together I will be referring to as a primer template junction. And that's the only time I'll write that. From now on, I'm going to write PTJ. Okay, so that's the substrate. What else does the enzyme require? Well, it needs all 4 deoxynucleotide triphosphates. Okay, unless you're replicating a polymer that has only one base pair in it, you're going to need the all 4 present. Okay, and then as I mentioned before, the let's see. So this is 4. The added DNTP must base pair with the template. For catalysis. Okay, so, oh, and the last thing I just want to point out. So a lot of times people will say the direction of DNA synthesis is 5' to 3'. So what are people talking about when they say that? Where's 5' and 3' up here? Because I see there's a 5' here, there's a 3' here, and there's a 5' there, and there's a 3' there. Okay? So when I learned this stuff, I thought that was infinitely confusing, okay? So I just want you to remember the following, okay? The chemistry of this reaction demands that the 3' OH is extended by DNA synthesis. Then you don't have to worry about the vagaries, I should say primer. The vagaries of which 5' and 3' you're talking about. It's always the primer that gets extended. And as long as you keep that in your mind, you never have to worry about getting confused about, are you talking about the template or are you talking about the primer when you say 5' to 3', because every DNA molecule has two directions in it, okay, both of which can be described as 5' to 3'.